The first thing you eat after a 16-hour fast is not just food. It is a command your body will follow for the next 6 to 8 hours. Most people think the fast is where the magic happens. They treat the eating window like the reward at the end of discipline. But biologically, the fast is only the setup. Because after 16 hours, your metabolism is standing on a knife edge. Insulin is at its lowest point. Fat oxidation is running quietly in the background. Cellular repair is active like a night shift cleaning crew. Then one bite lands, and your body flips a switch. Here is the counterintuitive truth. A food that looks healthy at lunch can be metabolically destructive at the end of a fast. It is not just what you eat. It is when it arrives. In this video, you will learn exactly what happens inside your hormones and enzymes when you break a fast. You will learn the worst foods that trigger an exaggerated insulin spike. And you will learn how to structure your first meal so fasting works for you, not against you. To understand why the first bite matters, you need to understand the state you are interrupting. By hour 10 to 12 without food, your liver has largely depleted its glycogen stores. The quick-access sugar reserve is gone. Your metabolism shifts gears. Insulin drops to one of its lowest levels of the day. Glucagon rises in response. Hormone-sensitive lipase becomes active inside fat cells. Stored triglycerides are broken down into free fatty acids. These fatty acids move into circulation and travel to your liver and muscles. They are burned for energy instead of glucose. Around hour 14, another process increases. Autophagy begins to rise more significantly. This is your cellular recycling system. Damaged mitochondria are broken down. Misfolded proteins are cleared. Old cellular debris is dismantled and reused. It is like your cells are cleaning out a cluttered garage while the lights are off. Quiet. Efficient. Purposeful. Growth hormone also increases during fasting. Its role is protective. It supports lipolysis and helps preserve lean tissue. By hour 16, your body is in a rare state. Fat burning is elevated. Insulin is suppressed. Receptors are highly sensitive. Think of it like dry soil after a long drought. The first drop of water will not be absorbed casually. It will be absorbed rapidly and intensely. That intensity is what makes the first bite so powerful. The fast builds the environment. The first bite decides how that environment is used. Now imagine what happens when the first thing you eat is fast digesting carbohydrates. After 16 hours, your muscle cells are highly insulin sensitive. GLUT4 receptors are primed and waiting. Your pancreas is ready to respond to glucose quickly. When glucose enters the bloodstream, insulin is released. But in a fasted state, that release can be amplified. The response is often larger than it would be after a normal overnight fast. Insulin does not just move glucose into muscle cells. It also shuts down fat release from adipocytes. Hormone-sensitive lipase becomes suppressed almost immediately. In simple terms, insulin flips the metabolic switch. Fat burning slows. Glucose becomes the primary fuel again. This is not because insulin is bad. Insulin is essential for survival. But context changes its impact. A bowl of oatmeal at midday is handled differently than that same bowl at the end of a prolonged fast. At midday, insulin sensitivity is moderate. After fasting, it is amplified. Think of it like stepping on the gas pedal of a car that is already rolling downhill. The response is stronger than expected. When insulin spikes sharply, fat storage pathways activate. Lipoprotein lipase activity in adipose tissue increases. Substrate partitioning shifts towards storage rather than oxidation. The paradox becomes clear. You spend 16 hours in a fat-burning state. Then one glucose-dominant meal closes the door in minutes. The food itself is not toxic. The timing magnifies its effect. The fast creates sensitivity. The first carbohydrate wave determines how that sensitivity is used. And for many people, that is where fasting quietly fails. If carbohydrates create a sharp metabolic turn, protein and fat create a controlled transition. When you break your fast with protein, insulin still rises. But the increase is moderate and purposeful. At the same time, protein stimulates glucagon. Glucagon acts as insulin's counterpart. Where insulin signals storage, glucagon signals release. It helps maintain a stable flow of glucose from the liver. Protein also delivers essential amino acids. Leucine in particular activates the mentor pathway. This triggers muscle protein synthesis. After fasting, your muscles are highly receptive to amino acids. It is like a construction site waiting for materials. Protein provides the bricks. Dietary fat adds another layer of control. Fat stimulates cholecystokinin release in the gut. This slows gastric emptying. Food enters the bloodstream gradually instead of flooding it. Glucose absorption becomes smoother and more predictable. Insulin rises gently instead of spiking sharply. There is also the hunger hormone, ghrelin. Ghrelin peaks before meals and drops after eating. Protein suppresses ghrelin more effectively than carbohydrates. This means breaking a fast with protein and fat extends satiety. Hunger stabilizes instead of rebounding quickly. Energy remains steady rather than swinging. Think of this first meal as a bridge between two metabolic worlds. The fasting state is one side. The fed state is the other. A glucose-heavy meal is like jumping off the bridge. A protein and fat-dominant meal is like walking across it deliberately. You preserve much of the metabolic work built during fasting. Fat oxidation tapers gradually rather than stopping abruptly. Muscle repair begins immediately. The goal is not to avoid carbohydrates forever. It is to reintroduce them at the right time. The first bite sets the tone. And tone determines the direction of the next several hours. Now let us clear the minefield. Because many of the worst fast breakers are marketed as healthy. First, fruit juice. A single glass of orange juice contains over 20 grams of sugar. Much of that sugar is fructose. Fructose is metabolized primarily in the liver. In high concentrations, fructose drives de novo lipogenesis. That means your liver converts sugar directly into fat. After 16 hours of fasting, hepatic sensitivity is elevated. Breaking your fast with juice is like pouring gasoline on a freshly cleaned engine. It ignites a pathway your body had just quieted. Second, oats and granola. Oats have a moderate glycemic index in isolation. But in a fasted state, their effective glycemic impact is amplified. Insulin response becomes larger than expected. Granola often contains added sugars and syrups. It becomes a sugar delivery system wearing a health label. Third, protein bars and meal replacement shakes. Many contain maltodextrin or sucrose. Maltodextrin has a glycemic index higher than table sugar. Protein does not cancel out the insulin spike created by added sugars. Fourth, sweetened yogurt with fruit. Plain full-fat yogurt can be a reasonable option. But once fruit compote or honey is added, the carbohydrate load rises quickly. After fasting, this can trigger the same exaggerated insulin response. Fifth, sports drinks and sweetened electrolyte beverages. Even small amounts of dextrose can activate insulin release. You may think you are hydrating, but you are also signaling storage. The theme is not that these foods are evil. The theme is that they arrive at the wrong moment. Context determines outcome. After a fast, the wrong first bite can undo hours of metabolic alignment. Even the right foods can be mishandled. One common mistake is overeating at the first meal. After fasting, hunger feels urgent. The brain interprets the fast as a deficit that must be corrected. But consuming excessive calories immediately overloads digestion. Blood flow shifts heavily toward the gut. Metabolic efficiency decreases. A moderate meal supports smoother transition. Enough to nourish, not enough to overwhelm. Speed also matters. Gut hormones such as peptide Y and GLP-1 require 15 to 20 minutes to signal fullness to the hypothalamus. If you finish your meal in 5 minutes, your brain has not yet registered intake. You are eating ahead of your own biology. Eating slowly improves glycemic control. Chewing thoroughly improves nutrient absorption. There is also the cortisol awakening response. Cortisol peaks naturally within the first hour after waking. Cortisol slightly elevates blood glucose. Breaking your fast immediately upon waking may amplify insulin response. Waiting 60 to 90 minutes allows hormonal levels to stabilize. Small timing adjustments create measurable differences. The first few days of breaking a fast correctly may feel unfamiliar. If you are used to carbohydrate-dominant breakfasts, your brain expects rapid glucose. Switching to protein and fat can feel quieter. This is not dysfunction. It is recalibration. Within several days, mitochondrial enzymes upregulate. Fat oxidation becomes more efficient. Energy steadies. Ghrelin spikes become more predictable. Hunger feels less urgent and more rhythmic. Metabolic flexibility improves. Your body becomes capable of switching between fuel sources without stress. The first bite rule is not about perfection. It is about communication. Every meal sends a hormonal message. Insulin says store. Glucagon says release. Growth hormone says preserve. The first bite after a fast speaks the loudest. Choose that message carefully. Fasting builds a powerful metabolic state, but refeeding determines whether that state is amplified or erased. After 16 hours, your body is sensitive, adaptive, and primed. A glucose-heavy first bite shuts down fat oxidation rapidly. A protein and fat-dominant meal preserves muscle repair and stabilizes insulin. Your metabolism is not random. It responds to context and timing. If you have diabetes, hypoglycemia, advanced kidney or liver disease, a history of eating disorders, or use insulin or corticosteroids, consult a qualified healthcare professional before practicing prolonged fasting or structured refeeding. Optimization must match your medical reality. The first bite is not just a meal. It is a signal. If you want to understand how hormones, enzymes, and timing reshape your metabolism beyond diet trends, subscribe to What Science Reveals. Because when you understand the mechanism, discipline becomes intelligent rather than restrictive.